Please subscribe and like my YouTube channel. So today we're going to try to be tackling, part one is going to be authentication, and then part two this afternoon is going to be something called authorization. And we've combined these to this mega conglomerate called auth. So who wants to tell me or take a stab at what the difference between authentication and authorization might be? Chris.
So authentication might be you are checking to see whether a person is a qualified user each time they go to something based on the credentials. Authorization would be you granted a computer or a session the ability to navigate your website, and they pass that token back and forth rather than the password.
That sounded very technical, and that is pretty close, right? So just in terms of non-computer, non-programming, what would the difference be, right? Authentication, authorization, all right? Different words, words mean things.
You have to put to website who you are, like your password or fingerprint or something.
Yes.
To log in, right? And then authorization is something that allows you to, once you log in, you have certain rights to do certain things.
Absolutely, right? So like a good example that Andrew likes to use is like, let's just say at TSA, right? You are getting checked in and you are trying to get through to the airport. You are being authenticated at security, right? You have to prove you are who you say you are, right? You have to show a driver's license or you have to show some sort of passport that says, hey, I'm claiming to be Evans, your boy, Wangtron. Here is my driver's license that says I am who I am because here's my picture, and that the wonderful state of New York has already checked who I am, so you can check this driver's license to make sure I am who I say I am based on this picture, right? Whereas authorization means something else, and we'll get to that this afternoon. Authentication first, just verifying you are who you are. Authorization allows you certain rights, right? Like I have this ticket, I'm authorized to be on this flight, and I can be on the flight, I will have my seat, and I will go from New York City to Shanghai, China. Cool? Questions on authentication, authorization? Awesome. So, what we want to do today is we want to finally log in our user, right? We want to be able to create a session for them. But before we can do that, what should we do? Before we can authorize them, we must what? We must authenticate them. We must prove that they are who they say they are. So what I'm going to do is I want to talk to you a little bit about how we do that. Realistically, what's going to happen is, who's going to do the lab about like the user and the user sign-in? Great. So good. Yeah! 100% lab completion. That died in Mod 1. That's okay. It's all about like comprehension, understanding, right? So what we want to do is I want to talk to you about like how we can authenticate somebody. So the way we do it is there's this gem called Bcrypt, right? I'll show you the coolness about it. Boom. Here is Bcrypt, right? If we log into something, then we probably check them how? What do you use to log into anything? Right, your username and your password. It says, this is my name, and in order to prove I am who I say I am, I provide a unique password that only I know, right? Like, let's see these common passwords. God, these, don't do this. Terrible, truly terrible passwords, right? What is this? 1, 2, 3, 4, 5, 6? I guess I should change my password. My noob, very good. Very good, very good. Google's actually pretty good. I would have not, oh my god, so meta, right? Like imagine like, oh, you could Google my password. It's Google. Right? Cool. Cool. I think when Andrew did this, like a password came with like Michael.
Yeah, Michael's in that list somewhere for some reason.
Oh. Yeah. Password for password, super secure. Super. So The idea is, if I were to create like a user, right, like a migration for them, I would have something called username, right, or like email address, whatever you want to use to log in, and some sort of password field in my database. Now, when I save these things, I save them as a string, right? Because I'm not going to save them necessarily as like a number or something else. I'm going to save it as a string. Should I save my user's password directly as it is in my database? Who says yes? Who says my username is Wangtron, password is Google, and I should throw that right into the database? Who thinks that's a good idea? Who thinks it's a bad idea? Okay. If that's a bad idea, what is another way? How can we possibly do this?
When you save it to the database, you encrypt it?
Yes. I should do something like encrypt this plain text password like Google or Michael or 1234566 into some sort of like unreadable, unrecognizable string of characters, so that if my database ever gets hacked, it essentially becomes worthless to the hacker because they can't tell what the passwords actually are. That make sense? So let's do it, right? I have here a migration, bloop, right? Remember this? God, I haven't done this in so long. What's that? Bam! Yep, don't worry about this. This will come in later, part 2. I just have something called username, all right? And I have a column in my users table called password digest. No questions whatsoever. Okay, just gonna move on. So in order to use Bcrypt, right, we have to name our password field password digest, as opposed to something like just password.
So we don't do password and then password confirmation?
We can and we will, and I'll get to that later on, right? So in order for us to fully recognize that we're going to be using something called Bcrypt, we had to change the way the column is to something like password digest. Otherwise, a common name for a field would be password, and it would be too recognizable and too common to determine whether or not I'm using something as specific as a gem called Bcrypt to encrypt my passwords. Does that make sense? Mm-hmm. So we had to rename it something so wild. Well, it's also because Bcrypt will digest your password and then spit you back out like a hashed key, right?
But it could be named that.
No, it has to be named password digest.
Digest.
Has to be named password digest. And in the words of Andrew, when I asked him earlier.
So the question was, why do I have to call this thing password digest? And my answer was, why do I put gasoline instead of milk in my car? It's just because that's what's expected. It's set up to look for a thing. It's apparently very funny.
Yeah.
So Bcrypt is just looking for something called password digest. So that's yeah. So that's it. It's just like this is what it's expecting. In order to get this to work, we just have to apply this.
I imagine putting milk in my car and somebody just driving by like, what are you doing? Anyways, password digest, yeah? This indicates to any user looking at my application on the back end that I'm using Bcrypt, right? So what is Bcrypt? Let's take a look. Bcrypt is a gem, right? A Ruby gem. And what it will do is it will hash out, actually it's better if we just show you, right? So I'm just gonna go into a regular IRB sesh. I know back in the day, little throwback, bloop, right? And so that I'm not in the Rails console. I'm just in a regular IRB. So first thing I should do is I should have, and I'll do it, gem install Bcrypt. Boop, 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 boop. Boop. Cool. So I'm in the IRB. And the first thing I do is in order to get access to it, I must require Bcrypt. Right? True. That means that it successfully required it. Remember when I required this like weird gem called Wangtron? And that gem sucks. So what can I do with Bcrypt? I can create a new password. So I can do Bcrypt. Wow, I can't spell. All right, I namespace password. And I can create a new password. So what's your favorite password? Wow. Please tell me that's not your actual password. Actually, you know what? Don't tell me. Got you, fam. And what do you think happens when I come out with this?
It'll change it to a.
This weird hashed object comes back. Right? Would this be safe to save into my database?
Yes.
Because it has absolutely no real recognizable correlation to my very commonly used password. Right? So it would be smart to save an object like this into my database as opposed to like say password1, which is easily readable and recognizable and like stealable, right?
But it can still be traced back to password 1 though.
It can, and I'll explain, right? So what do we have here? Let's take this and let's copy it. And let's see if this equals to password1. What do you think?
False.
That's weird, right? But if we take the return object, right, which is this string, and we compare it to, what do you think will happen? It should, because if this returned true, unfortunately for you, it does you no good in terms of protecting you, right? If I have a username and I have this hash string and I just compare it, I can just log in. I can just figure out what your password is if this were to return true. Does that make sense?
Yes.
I need to not be able to return true. So what's the difference between what this is and what this was?
That's past tense, really.
So let's check. What do you mean past tense? Boop, 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 boop. All right. What is this? Looks like a string. Let's check. Psych. It's not, right? And we know it's not because I'm calling it on this new. So this looks like a string is actually a Bcrypt password object. Yes?
So let's see what happens if we do that weird string equals Bcrypt password create password.
You mean this?
Yes.
And you wanted to do what? Double equals to what? This?
Bcrypt password create password. The first thing.
So password create will make a brand new one.
Oh, okay.
Right? Password new does something slightly different. So I can run it with create or new. It's up to you. Okay? Sure.
You can do create.
Like I thought it would be the same. I thought it was more.
Sure. I'll play. I'll play. Like this? False.
So it's different every time.
Well, I'll just run it a bunch of times and see what happens. Sorry. Here we go. Do 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 do. Boom. 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 So weird. Oh. Boom. 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 Ba do 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 do. Right? Each time it's different. Why? Why is it not giving me the same thing every time?
Great question.
Thank you.
So it's more difficult to reverse it.
It makes it impossible to reverse engineer, right?
Well, I was gonna say, doesn't it like salt it in a certain way that it like doesn't do it the same way, but it makes sense somehow?
Yes. Now, if I run some sort of algorithm to change password1 into a hashed object, which is like a jarble of like strings and symbols and numbers, I need to add in some sort of randomized value in order to create something new and unique every single time. Does that make sense? If I always put in password1 and I don't add in any extra data, in my algorithm, I will always produce the same hash. Does that make sense? So like if I were to take a word like word, and my algorithm, very complicated, is I just reverse it. right? Very good. If I take the same word every single time, it's going to come up with the same thing. But if I add in some weird random string every single time, it'll hash differently. Does that make sense? Like if I go into my algorithm one way and I don't add any unique random value, it will spit back out the same thing every time. So if I don't do that, in theory, I can just collect all of these different hashes and just compare them to regular strings. Eventually, it will crack the code. Does that make sense? Like if I took like the top 200, 300, 400, 1,000 passwords that are common, and I started comparing them against all the hashes that I can steal from all the databases, eventually, I'll be able to figure out all the passwords. Unless there was some sort of randomized data inside each one that made the hash different every single time. No matter what I put in, it will be different. And so I can't really compare them.
Is that what you call a key?
That's what I call a salt.
Assault?
Right? I think there's a GIF in here. Come on, Andrew, don't let me down. Oh, I need to...
Command Shift M, or Control Shift M string on the review.
Yes, preview, baby. Bam! Where's he at? Nope, nope, nope.
There's a salt band or somewhere.
I know you had him in here. He's my boy. Nope, oh, just kidding. Anyways, I meant Salt Bay. Sorry. Saws. Done messed up. Anyways, so what I want to do is I want to add in some random value, right, every single time. So when I go through my very complicated hashing algorithm, it will come back differently. Does that make sense? And this random value is known as the salt. The salt, I think, is a combination of like what operating system you're on, the date, time, and like a couple other like random characters. So it will be different every single time I run it. Does that make sense? So I'm adding in a salt in conjunction with your plain text password. I pass it through this Bcrypt algorithm, and it will produce a unique hashed key.
Doesn't it think you need, wouldn't you need to save the salt for later in order to compare the passwords?
What a great question. Let me check, right? So let's just do, right, pass, right, equals this Bcrypt password, right? Now this pass, right, is this. I can, in fact, remember, what is this? It says special object, which means it was instantiated. So probably somewhere in the defined initialize, there's an attribute, right, for that randomized salt. If that is an attribute, I should be able to call it.
But that's, you need to put that, you would need to put that in the database table, right? Your system doesn't want to.
I need to save the object, the Bcrypt object, right, into my database. And then what it will do, and according to the docs, is it will check to see, man, where is the Bcrypt? It's not this one. Is it this one? Okay, just forwarded me right back to the same one. It's embarrassing. Yeah, you know what I'm talking about, Andrew? Where it checks the...
Oh, yeah. Scroll up, go to the source code. Scroll up, go to...
Oh, yeah.
Lib, Bcrypt, password.
There we go. This is what I'm looking for.
Take some command plus action on that.
Yeah, give me that, Chris Brown. So remember, right? I have a module here. Bloop, bloop, bloop. Can you see this? This is cool. I have a module here. Inside this module, I'm defining a class, which is why I have to use the namespace that I do, which is Bcrypt with the namespace password. So Bcrypt being the module, password again being the class. It inherits from string, so it has a lot of those string methods already built in. And look at this, add a reader, salt. So it must do something with that. So what I'm checking here is when I look, where is this? What does this look like to you? The double equals, right? Which is inheriting from what? Probably like object or something. Remember I mentioned this in Mod 1? It's called monkey patching. I can go into a class and override certain things, right? Like I can literally override any method I want if I define it. And based on inheritance, it will look under the first time it was defined. Right? So I'm defining it here, so it's not going to go to my string class to look to see the comparison operator. This double equal sign is overwritten. So if it's overwritten, right, and it takes in a secret, like the password, what does super do again? It calls in from the parent, right? It calls in the parent class. So if I'm supering, right, Bcrypt engine, that means there's a different class under Bcrypt, right, with the hash secret method that's going to take in the actual secret and the attribute of @salt, and it's going to re-look up what it originally was.
So just now when you were comparing the two things, would it not have worked if you changed the order?
Exactly. So, all right, I have pass, right, and that's the what? That's the object. Sorry, just kidding. That is the object, right? So I can check pass double equal, right? Password 1. But remember, this is a method call on the Bcrypt password. So if I did, however, password 1 double equal sign pass, this will return false because I'm calling this double equal on the string. Super tricky, yeah? So remember, I'm calling the double equal on the Bcrypt password object, checking to see if it will evaluate to this, and it's true. Versus the actual comparison operator from the string that we know and love with the object, and it will return false. This is very important to understand. What are your questions on this? Bloop, bloop, bloop.
So if you don't understand anything, at least understand that, right?
Yep. Yep. Remember, the comparison is being overwritten.
I'm a little bit confused about the tie-in to the database because you defined the attribute to force into a string. So if you go later to pull that string back out of the database, that just kind of Bcrypt magic at work.
That is Bcrypt magic at work, and so we'll take a look, right? So what is pass again? Oops. Oops. Pass will return this string looking thing. And what I can do is, with the magic .new, and I pass in that salted hash, I can still double check to see if that's equal.
Oh, so password.new just takes a string.
It will take in a salted string, and it will break down the salt, and then it will do its best to reverse engineer to compare against whether or not it evaluates to another string in the truthy value. This has never been broken, so to try to reverse engineer and understand how this works, you are past Andrew and I's level. This has never been broken. Bcrypt is one of the best and most secure ways you can salt and store your passwords. So this was done by like a bunch of like MIT engineers years ago, and it's like a one-way sort of algorithm. And the example that we usually give in terms of like trying to teach it is imagine like a meat grinder, right? And you take like a cow, if you're not into that kind of stuff, take some celery, right? And you're like a vegetable grinder, which is somehow better, and you grind it up, right? This is like what grinding looks like. When it comes through at the end, can you recognize it necessarily as the original vegetable or fruit? Not really. But can you test that mash to see if it was from the original fruit? If you had a piece of the original fruit, right, can you test that mashup to see if it came from that original one? Sure. Yeah. Can you check? Can you check? All right. So it's unrecognizable, but there is a way to check to see if it was the same one. And that's kind of what's happening through Bcrypt. Because you can't pass that vegetable mash back through the vegetable grinder and get like the whole fruit again. Does that make sense? That's a one-way transformation. All right, thank you. Yeah, like I like making that face, like, oh, right? It's a one-way transformation.
Well, the Star Trek, they transport, they transport people through that. Beam up Skype, they can do that.
No, because you come back on the other end looking exactly the same.
Yeah, but they would sample the person, they put it back together.
Except we don't ever put it back together.
That's what's okay.
Yeah.
So it's like that transporter actually tore that person.
Yes, yes. Season 1 is only 3 episodes. Yes.
Could someone with this access to Bcrypt, like why can't someone with access to Bcrypt use it to compare passwords?
They can. Anyone with access to Bcrypt can compare, and this is very important to know, right? This is a concept known as rainbow tables, where I can take a list of literally 100,000, 100 million words or common passwords, and I can compare each one doing this, right? I can make bcrypt password.new, pass in what I know and I've stolen from the database as this string, and compare it against every single password in my 100 million password database. This is known as a rainbow table. The problem is Bcrypt was designed to operate extremely slowly. So the processing power to make a bcrypt.create with a string is computationally expensive. So I would have to take a ton of time to compare them. In order to compare about 100,000 passwords, it would take several hours. That's not too bad, but I would produce one password. And that's not even considering that at 100,000, I would even crack it. So like, let's say your password is password, probably get it fairly fast, right? In several hours. But if your password was like, I love getting my free monthly Hulu, and then like capital U, that's like completely different than this, all right? Not saying I do this, but let's just say that was my password, right? It would take forever to break one password. It's not impossible, but yeah, it's very computationally expensive.
Also, is there a function that hashes something without a salt?
Is there a function that hashes something without a salt?
If you wanted to, 'cause I
You could just make your own, like how I did dot reverse, and it just came up with something. You can make your own algorithm.
If we wanted to take this long string and remove the salt and stick the salt onto our password 1, is there a function to just straight up turn it into another hash without adding another salt? But basically that breaks up the creation password.
So you're talking about rehashing it without extra salt. Oh, okay. Okay.
Sorry, one more time.
Okay, so from my understanding, password.create does 2 things. It adds a salt and then it puts it through the hash. Is there a way to do just the second part?
No.
Yeah.
Like you're saying just hash it without the salt.
Yes.
I don't think there's a method that exists.
No. It wouldn't make sense to make a method like that because then it's easily reverse engineered. Because it will always produce the same.
That's what I'm trying to.
She's trying to hack into everybody's stuff.
Yeah.
Yeah.
Well, that's what a rainbow table is. It's just like,
Yeah.
oh, let's say, like, for example, the algorithm you're using is like HS256, I think is what they use here. Whatever, like, if you take a bunch of passwords and run them through the same encryption algorithm, you will always get the same result. So, if I can kind of rely on this like table of hashed common passwords, and I get access to your database, I can match those hash versions with my rainbow table and steal your user's information. The salt makes it so that that is no longer viable because it adds a bit of randomness to each password. And it's it's a combination of like some info about operating system, the current time, and I forgot what all goes in there. But
it's a lot.
It's a lot of stuff.
It's a monster. So, are we cool with Bcrypt and its one-way transformation, yet the ability to still verify and double-check against a plain text string? What was that? Who?
I mean, when you put it that way, sure. I don't know if I can do it like on a test right now. Like, give me a laptop.
Not really a test. All I need you to understand is this.
Yes.
Right? Once I get the Bcrypt object, I just need to compare it against the plain text password, understand it returns true, and also understand that I cannot reverse engineer it, which is why it provides the security.
So then how does it connect to password digest?
Very good question. Let's build it out right now. Right? Let's connect it. So I have, in my migration, a password digest. So my schema says password digest, right? Schema, right? So what I want to do is I want to be able to like log in at some point. So I can man, I need. Did I not make this thing? Where's my form? Here we go. User's new, right? It just says sign up, form for user with the username and the username. So let's take a look at that. Look, this is what it. I turned my server off. Okay, just kidding. Browse. Okay. Cool. Boop, boop, boop. So it's just a sign up, right? With the username. But now I want to be able to add in some sort of password field, right? So how would I do that? Right? So do you remember how I explained how Form 4 works? It's going to call the @user.username and @user.password. Do you remember that? Where I basically said it's going to do something like @user.password. And if it returns nil or empty, it recognizes, right? If all these fields are nil or empty, it's going to recognize that this is like a new one versus like the edit. Right? Is that what you're going to say?
I know the password digest.
Correct. So that's what's going to happen here, right? I'm just going to call .password. So who thinks this is going to work? Who thinks this is not going to work? Be good. Very good. Didn't like that? Oh, probably doesn't like this. Punk. Cool. So it says undefined method password, right, on my user object. Right? It's looking for something like password digest, right? But we want to use password because password is cool. So how can I create this password method in my user class? Let's do it, right? In my controller, I want it on the user class, right? So I can probably just do something like this. Why would I put it in the controller if I'm calling it against the model? Yeah, did you forget about this? Old boy active record? Yeah. So what would happen here? Would it be okay?
Can you do the setter method?
Come on. Should be okay. Come on, get users new. There we go. So this password is fine. All right? Because I hard-coded this password method. So far, so good? So realistically, probably going to create some attribute called password. But what does this look like to you? It's our good friend. All right? I just found this recently, thanks to Andrew. You guys like shortcuts? If you press R tab, it gives you the reader. Yes. Wait, what? No, P does not give you that. What is it, W?
W.
Yeah.
When you want to enter something, you want to be able to change password.
If I did the reader, what would it give me? If I did the writer, what would it give me? Let's do it. Bloop, right? And this is like some junky, plain text, garbage password, all right, that I don't want to save into my database. So what I don't want to see is this. I don't want to see this, right? Because then I would be saving the plain text password into my database as an attribute of password. Does that make sense? Remember, if I call user.first right now, if I were to create one, and I call user.first.password, doing this would give me a plain text password. It will come back as password 1, or 1, 2, 3, 4, 5, 6, or whatever password I put in. Does that make sense? You guys want to see it? Here. Trash. Trash. Trash people. All right, boop, boop, boop. What is it, 23? Auth. If I were to do something like user.new, and I put in the username of Chrome Boy, right? Is that cool? I probably want to access it later. So you crank that Chrome Boy, right? Oh no, I'm missing an end. Embarrassing. How did it even compile? Can I use reload here? Yes. Oh, by the way, I don't have to like break out of the console and go back in, just with reload. Right? So I have this, right? Now I can do u.password, right? And I can assign it a new value like password. Nah, that's a terrible password. 1, 2, 3, 4, 5, 6. That's secure. So now, if I were to go U, it has a new, oh man. It should have come up here. Interesting. Either way, I can just ask for it and it'll give it right back to me. Do I want to do that? Do I want to store these plain text passwords in my database? Say it with me now.
No.
Very good. Thank you. So how can I, right, instead of doing the writer, which is this is what it's going to give me essentially, I'm going to refactor this to plain text password. Is that okay? So just in case you forget, I'm just saying this is a plain text password, right? So what can I do now?
Change that.
Right? Do I want to assign it to be add password if I don't have the attribute of add password? When I'm in here, right? Remember, what is self? The user object, right? On this instance variable for this instance. And I have an attribute called password digest. Yeah? And I want that to be equal to a new Bcrypt with the plain text password. Because remember, now I'm going to get back what? That weird salted hash. If I run this with a plain text, I'm going to get back like a salted hash, like a weird random string of characters. Right? And then I want to assign that to be the password digest of my user. Following along? So far, so good? Okay, so what I'm trying to do here is, you see this password digest? I want to be able to do something like this. I want to assign it the... Very good. Right? Crypt. And I want Miriam, what's your favorite? What's a definitely not a password you use? Favorite password? Chair.
Answer.
Sure. Ice cream. Right? Cool. What's gonna happen? I'm sorry. Oh, I meant .create. Right? Oh, man, I done messed up. Where's my gem file? Give me that, Chris Brown. Now I gotta rebundle. Bundle. Cool. Let's get back into my Rails console. Let's do this again. And let's do this. So now if I ask for you, I'm going to see bloop, 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 bloop. So all I did was I made a new user, right? Called on that user. So look, right here, I just said, for this user, the attribute of password digest, right? Self.password digest, I want it to be this bcrypt password. And it's going to return me this hash. So when I call user now, I can see username Chromeboy, password digest of this very long salted hash. Does that work? So now, if I were to say in my fields, at password, right? If I were to reassign this, because remember, it's just calling at user password. Once I hit submit, it is going to try to assign the password what I have, right? If it's going to try to assign it what I have, in my user model, if I have written over it a password equals with this bcrypt, that means that running this method will assign the attribute of password digest for my user to this bcrypt password. Let's see it in action. Cool. Any questions on this so far?
So, just real quick, within a session, so to speak, the U object or the user object that's instantiated in Ruby has a password class variable, but that does never get translated to the database.
It has a what?
It has a password class variable, the way that you define it, but that doesn't translate to anything in the database directly.
Where are you getting the class variable from?
The adder reader creates a class variable.
The adder reader creates a class. No, I'm sorry. The adder reader is an instance variable.
Sorry, that's what I mean.
Okay, sorry, it threw me off. You asked one more time?
So you have this instance variable at password on the Ruby object of class user, but the database objects that are recreated, if you were ever to call one that didn't exist in the Ruby session, that would not have that password.
Correct. So we don't need this. We actually need to return. Whoa, that was aggressive. At password digest.
Why do we need that?
Because we don't have attribute password. Remember I showed you how it didn't come up? Yeah, but I would like the ability to just call password.
You already get password digest because you're comparing an application record.
Mm-hmm. Questions on this? Awesome. So, boop, boop, boop. Cool. So my username could be very good test data, like username. Cool. Can you see this? And what's a very secure password? Okay, cool. So what I want to do is I want to pause this. All right, because it's going to hit the create, right, when I submit. Yeah? I want to be able to hit. So I should be in my bybug. Just get out of this real quick. All right, cool. So what are my params? So I have password here is nuts. Yeah? So I want to be able to somehow do user. Wait, I think I have @user, right? No. Create. With the user params. Right? That's normally what we do. Right? Except here we don't have user params yet. We have what? Dot require user. And then we need to permit what? What attributes? Username and the, yeah? I think I'm missing one, no? Yeah. I don't have Bcrypt here. Sorry. I to bundle. Fail. Cool. Cool. I bundle. So we have a squirrel and loves his nuts. Squirrel. Right? Nuts. Cool. I should have saved that code. Actually, I think I have it. Boom! Yes. Cool. Sweet. So what it did was it permitted these, all right? And when I ran password and I tried to overwrite it, it saved it as this hash into my database. Yeah? Questions, comments, concerns? How that worked? Because I'm going to call password equals, and then I'm going to update the password digest column of my user model. Yeah? So now that we have this, cool. Now that we have this, we want to be able to somehow authenticate the user, right? So if I know that I now am saving the password properly, not as like a plain text password, I want to be able to authenticate and actually check that user. That make sense? So what do I need? So here in this create, I probably want to do @user equals to user.create with those user params. I'm just going to rip them from here. Look up. Look up, look up, look up, look up, look up. Any questions on that? All right. That sweet, sweet refactor. Say again?
Sorry, can you remind me why we make user params?
When will you ever call user params?
Only in there. I mean, no, why, no, I'm sorry, why we have them for it?
What?
Like why we don't need to put params require and create.
In this?
Yeah.
Because then if you run the method, you will see what comes out, like what parameters actually come out, and you want to keep that secure. Any questions on this? Cool. So now we need some sort of like sign-in functionality, right? Yeah. Where are we redirecting to after this? The user? Oh man, I need to make a show now. Boop, boop, boop. Oh, snap. Just kidding. Show? Show. Cool. And what is this? Just H1. User show page. It's fun to watch you guys all like stare at that. Nothing was happening at all whatsoever. So we have what? Just like a p tag. We have @user.name, username. Oh yeah. Dot. Bloop. Nice. That's it.
How did you do that?
I have Rails snippets, so it's just Command Shift period. Cool. So if I were to make a new, no, I'm not. Huh? Work you. Bcrypt will slow your app down just a little bit. So Who do we want to, what kind of username do you want?
Dog.
All right, dog. And what's your password, dog?
Please.
Huh?
Please.
Fleas? Just for you. Just for you, Johnny.
Thank you. Go. No looking. No fees.
Okay.
Do you have a route for it?
Oh, I don't. Smart. Let's just drop that real quick. A little show action. A little bit of that, a little bit of that. Let's just start over. Do the whole thing right. You know what I'm saying? Snoop Doggy Dog. And Dre. Dr. Dre. My password. Oh. My controller. Y'all done jack me up. Show. Right? And I'm gonna do a little bit of this. At user equals to user.find params ID. Yeah? Give me that.
There you go.
Yep. Cool. So now I need some sort of like authentication method, right? Let's see what Bcrypt has for authenticate. Dang it. Yeah, you know where he keeps the authenticate engine? Otherwise,
I think it's your password. Go back to password. Oh no, I'm sorry. Authenticate, I think is from oh my god. It's a Rails thing. It's not Bcrypt.
oh yeah, active model, right?
Active model. Yeah, active
Okay.
model,
So I'll just do it myself, all right? Boom. So I need some sort of method, right? And what does authenticate do?
Checks the password against the Bcrypt.
Okay, so I need some sort of plain text password, right? And then what? You guys them?
just quick heads up.
Oh snap! I think I can do it in like 5 minutes though.
Okay.
So what does Bcrypt do? What is authenticate doing? What should it do? Right? Right. Dot new. Right. With what? Plain text password. And what am I comparing it against? Right. And this should return what? A Boolean? Right? So that means that if I run this authenticate method, then what? Then I should be authenticated.
Right.
Does that make sense? So this whole thing, all of this, has secure password. If I put this line inside my user model, it will rewrite all of this. This is the adder accessor for password, password equals, and authenticate.
Are you kidding me?
Who's mad?
Who's mad?
I'm very mad.
Who's glad they understand what's happening under the hood as opposed to, hey, please use secure password, good luck.
I used to secure password.
So mad.
Ah, so mad. All right, cool. So I'm going to leave it here because it's lunch. Now that we know that there's some sort of method that we can use to authenticate, let's think about how and when we're going to call that authenticate method with the username and the plain text password to see if we can then authorize them to use the rest of our application in the afternoon. All right? Great. Thanks for your time today.